Good morning. I hope you guys are having a great morning. This is your mini lesson. Remember, this is just a reminder that whatever is on this video, you need to write down on your notes like this, and you can also get a scratch piece of paper if you need to use a scratch piece of paper as well. But after this video, you need to upload this notes and have everything written, at least everything written that I do on the video. If you want to put more than that, you're more than welcome to do that, but you at least need to have those. And you need to have what I've written on here exactly on your notes. Also, make sure you look at the due time and get this submitted before the due time, okay? So let's go. Okay, so in 3.1 we talked about this function, which is y equals a times the quantity of x minus h quantity squared plus k. We called this the vertex form, okay? And the reason we call this the vertex form is because the vertex is going to be hk, okay? So also, if we need to find the axis of symmetry, I don't think we talked about this here, but if we need to find the axis of symmetry, the axis of symmetry would be actually x equals h, okay? Because if we were to draw this, and we had our random HK like this is HK, our axis of symmetry would go right down here, which it would hit this at the x value, which is h. So that's why it's x equals h, okay? There's other aspects of it, but this is the main part of vertex form. The rest of the things that we talk about with max and min, and then we're going to talk about domain and range and increase and decrease, it's kind of the same depending on each form. Like I said, this is the first form we talked about, which is vertex. The second form we're going to talk about is the standard form. And standard form is, and they have it as f of x, oh, you can't see that. They have it as f of x, but remember f of x is the same as y, so I'm going to write it in the equation form. Y equals ax squared plus bx plus c. Now this is a form that you learned in Algebra 2 as the standard form for quadratics 2. So we have started with a vertex and now we have it in standard form. Now, when we're talking about standard form, I am going to talk about some properties of standard form. So I need you to get your highlighter out. The properties of standard form here, remember, if A is positive, which means A is greater than 0, it's going to open up. So here is where A is positive. If, here it is. Here's my blue one. If A is negative, which means A is less than 0, then it's going to open down, okay? We kind of are familiar with that as when we were talking about the vertex form. If there was a negative in front of this, we know it opened down. If it was positive, it opened up. And many of you noticed that when you were going for your data because your fish went in a parabola like this that went opened down. So your A should have been negative. And if it isn't, then maybe you should change it. Okay? So, now this is the transformations that we're talking about, but we're not going to focus on that right now. What I want to focus on with this standard form is this right here, that the axis of symmetry is x equals negative b divided by 2a. Okay? So a negative b divided by 2a. Now let me use an example. Ooh. Pause, please, because I forgot to bring my problems up. Hold on. You won't know it's paused because I'll just turn it right back on. Okay, so let's use this example as y equals negative x squared plus 5x plus 9. Okay, let's find the axis of symmetry. Well, we know that A is equal to, remember there is an understood 1 right there, so A is equal to negative 1, B is equal to 5, and C is equal to 9. Okay, so we want to find out what the axis of symmetry is. So we want to find out what x is. So x is going to equal negative, and then b is 5, times 2a, which is negative 1. So we have that negative, we have 5 over negative 2. So a negative times a negative gives us a positive, so the x actually is 5/2, or if you don't want the decimal, you can do 5/2 is what, 2.5? Well, I hope so. Okay, so the axis of symmetry is going to be x equals 5/2. Now remember, here, we can write this as f of x. Remember, y and f of x are the same. So if we want to find out the vertex, what this is telling us here is that the vertex is, the x value is going to be the negative b divided by 2a, and then the y value is going to be this f of all of that. It's really not as confusing as you might think, because remember, y is the same as f of x. Well, we know x is 5/2. To find our y, we need to find f of 5/2. Okay, so let's go ahead and fill this in. We have negative, well, instead of x now, I have 5/2 squared plus 5 times 5/2 plus 9. So if we enter that all into a calculator, I'm going to enter negative 5 divided by, oops, not times, sorry, divided by 2 squared, excuse me, sorry, plus 5 times 5 divided by 2 plus 9. Notice I just put it exactly like I had here. I'm going to put enter, and I get 15.25, or if I want to put it as a fraction, it's 61/4. Okay, so that's my y value of my vertex. So the vertex of this equation would be what my x value is, and I'm going to go ahead and put it in decimal because they're nice decimals. I'm going to have my x of 2.5 and my y of 15.25. So that is going to be the vertex of this in standard form. Okay? Now, if we want to, what else? Oh, also in here, you will notice that the c, where the c becomes important is when you're trying to find the y-intercept. The y-intercept and c are the same because remember, the y-intercept is where x is 0, so if we put all of this away, then y is going to equal positive 9, which is also equal to c. Okay? Because we put 0 in here and 0 in here to find our y-intercept. Okay, so that's how you find the vertex of a standard form. What we also want to talk about is our max and our min value. Okay, when you talk about a value of max and min, I want you to think of the y. Whatever the y value of your max and your min is your min value and your max value. So in the case that we had right here, oh, the other thing I want to say is that both of these, your max and min, is always your vertex, okay? It is also always associated with your vertex, so it's going to be the y value of your vertex. So in this case here, our vertex is 2.5 and 15.25. How do I know if this has a max or a min value? Well, if A is less than 0, or if A is negative, then it's going to be a max value. If A is positive, then it's going to be a min value, because remember, this is opening up, and this one is opening down. Now in this case, this is going to be a max value that is equal to whatever the y is. So in this case, it's 15.25, because we're only talking about the y. The y is the one that is going to max out in this case. Your x is going to open up still forever and ever and ever, okay? Now, also in standard form, wait, hold on. I think I'm getting ahead of myself. Let me just check my notes here. Where's the other side of this page? Yeah, hold on. I don't have the other side of the page. Okay, so I got a little bit ahead of ourselves. On this other side, it does talk about the max and the min. And it talks about right here, the minimum value is when A is greater than 0, and the maximum value is when A is less than 0. And see here, we have open up, minimum, open down, maximum. Now this is a little typo, just cross this out. It should have just said this, okay? Remember that this right here, get this, is equal to your y value, or your y coordinate in the vertex. In the vertex. Okay? Remember that this right here, f of negative b divided by 2a, is actually gives us the y value in our vertex. Okay? And I just showed you how to do that. Now, what is so great about finding the domain and range when we're talking about quadratic functions is every single time the domain is always going to be all real numbers, because it's either going to open up or it's going to open down, and the x is going to continually go out. As it's opening up, it is continually going on forever and ever, and as it's going down, the x is continually opening and getting bigger and bigger as it's opening. Okay, so whenever you have a quadratic function, it's always, the domain is always all real numbers. Now the range here is always associated with either the min or it's associated with the max value. Okay, so when we go back to our example, right here, when we're talking about this function and we want to know what the domain is, well, I already told you every quadratic function is going to have a domain of all real numbers. The range is associated with our, this case, maximum value, which happens to correspond with the y coordinate part of the vertex. Now, since it's a maximum, every y is going to be less than this 15.25. So we can write it in set notation, and it's less than or equal to 15.25, or we can write it in interval notation. So the smaller number is going to be included because the smallest number is, the smallest number is negative infinity, and the biggest number is going to be 15.25 because we can't go any higher than 15.25. I almost wrote that wrong. Sorry about that. Okay? So you can either do set notation or you can do interval notation. Now notice here, they have it here. For a maximum, y is less than or equal to, remember this is the y value in the vertex. For a minimum, y is greater than whatever the y value is in vertex. But remember, you have to write it either in set notation or interval notation. Okay, the last new thing that we are going to talk about is increasing and decreasing. When we're talking about increasing and decreasing, we are always going to talk going left to right, just like how you read. As we're traveling towards the vertex, we are decreasing. Notice how we are decreasing. We're always traveling towards the vertex first because we're reading left to right. But then, once we hit the vertex and we're traveling away, we are now increasing. Okay? So for minimum, we are going to be decreasing to whatever the axis of symmetry, because remember, this is the axis of symmetry. So whatever you have as your axis of symmetry is going to be decreasing to the left of whatever your axis of symmetry is, and then increasing to the right, whatever your axis of symmetry. And I'll do the example here because we actually have a maximum for this one. Okay, now this one, again, we're reading left to right. We are going to be, because we're traveling towards the vertex, we're going to be increasing first. Once we hit the vertex, we're going to go away. So now we are decreasing. So in our example here, we're going to be increasing. Okay, remember here, increasing first to the left of, and what's our axis of symmetry? We said it was right here. Ooh, right here. I didn't put axis of symmetry, sorry. Of x equals, I'm going to put 2.5, and then it's decreasing to the right of x equals 2.5. So the only thing that changes is the increasing in left and decreasing in right. The axis of symmetry is our description. So here, in the case that we were just doing, we were saying this was x equals 2.5. So as we can see, it's increasing to the left of x equals 2.5, and then it's decreasing to the right of x equals 2.5. So that is how you describe increasing and decreasing. I'll do some more examples here in just a minute. Okay, now that was our standard form. The third form that we're going to talk about today, where is it? Is our intercept form. And that form, where is my notes? There it is y equals a times the quantity of x minus p at times the quantity of x minus q, where p and q are the x-intercepts. Okay? These are the x values of the x-intercepts because the y values are going to be 0. Okay? So, I'm actually going to do, let's see, we're going to talk about this one right here. We're going to jump to this here, and we have the P and Q, where P and Q are the x-intercepts. Now this time, the axis of symmetry is halfway in between the x-intercepts. So we're going to take the average, P plus Q divided by 2. Okay? And the same thing, to find the vertex, we know that the vertex is going to be P plus Q, and that is going to be the x value, and the y value is going to be the f of whatever this number is. Okay? So let's put this to practice. Let's go. Let's do, which one did I want to do? Let's do number 4. Okay, remember, it's going to be f of x or y equals a times x minus p and x, minus q. I was looking at that because I wanted to emphasize it and made me write the wrong thing. Okay, so that's supposed to be a minus. So, we have here plus 4. Since it's minus p, the only way we can get plus 4 is that if p is equal to negative 4. Since it's minus 3 and this is minus q, that q is equal to 3. So it's like it's opposite of what's inside the parentheses. So if we want to find, and this is where I'm going to start using my scratch paper, if we want to find the axis of symmetry, we're going to need to find P plus Q divided by 2. So it's going to be negative 4 plus 3 divided by 2. So we get that this is equal to negative 0.5 or 1/2. So we know the axis of symmetry is x equals negative 0.5. Now we want to find the vertex. Now we have the x value of the vertex. We need to find the y value of the vertex. So we're going to do f of negative 0.5. So wherever we find an x, in this formula, we're going to put in negative 0.5. So we're going to have 4 times